problems, remaining problems of module 2, that is the hexagonal pyramid. There is another problem on pentagonal pyramid, and there is a problem on cone, and there is another problem on square pyramid, and there is another different kind of problem on square pyramid. So these are totally, I'm having 5 problems today scheduled for completing today. So in the last class, we have seen this problem, a square pyramid problem, wherein the square pyramid is resting with its base on HP, and one of its base edge is inclined. One of the base edge is inclined, it is resting with one of its base edge, and the axis is inclined to HP by 45 degree and VP by 30 degree. So in the initial position, you can note here, so it is the base edge inclination. So initial position is edge inclination problem or side inclination problem or side resting problem. That is why we have drawn the initial position such that one of the side is to the right side here. One of the side, we are drawing it to the right side and it is vertical, right? And in the second position, always I told, so the axis inclination will be considered in the second position. Whatever the inclination of the axis with HP, that is what 45 degree here, we have taken that 45 degree. Coming to the third position here, we need to find the beta angle here in this third position. Why we have drawn the beta angle here is, we have mentioned that the axis is inclined to VP by 30 degree. That is the true inclination of the axis is given, but in the second top view, the axis is not in true length, it is in apparent length. As the axis is in apparent length, so we have to find out the apparent inclination. That's what the beta angle. So we have found the beta angle in the third position, and to that beta angle, we have rotated the second top view. Then we have drawn the projectors upwards and we have obtained the final front view. The final front view has been obtained in this manner. Then coming to the next problem of today's problem. So it is a hexagonal pyramid of base side 25 mm and axis length 60 mm. It is resting on HP, one of the corner of the base. It is a corner condition problem. It is not the edge condition problem. In the previous problem, it is an edge condition problem. That is why on the right side, we have taken one of the edge vertical. Here, it is a corner condition problem. It is not an edge condition problem. So we have to take one of the corner on the right side. We have to take one of the corner of the solid on the right side. So this is what we have taken here, one of the corner on right side, and the two base edges containing that corner make equal inclination with HP. Whatever the inclination of this edge DE is equal to the inclination of this edge CD with HP. That is what this statement tells. The two edges containing the resting corner make equal inclination with HP. That is what it is here. So these two edges are making equal inclination with HP, and this is the resting corner. The resting corner, we have to take it on the right side. Then we have to draw the projections here. When the axis of the pyramid is inclined to HP at 40 degree, so this inclination they are given. It is all similar to the previous problems as I told. So the second position always, it will be the inclination of the axis with HP. Here they are given the axis is inclined to HP at 40 degree. That is where we have taken 40 degree here. While drawing, we are not considering the axis inclination. Instead, we are considering the base edge inclination. What is this base? Whole of the surface of the base. What inclination it is? That is, inclination will be 90 minus the inclination of the axis. So if the axis is inclined at 40 degree, then the base will be inclined at 90 minus 40, that is 50 degrees. So this inclination we have to consider as 50 degree here. And in the third position, so the axis appears to be inclined to VP at 45 degree here. You can note here in the previous problem, we have obtained the beta angle. But here in this problem, the beta angle is not required because they have mentioned here the axis appears to be inclined to VP at 45 degree. Apparent inclination of the axis is directly given in the problem. Apparent inclination is given, so you can rotate the apparent length of the axis to directly the apparent inclination, that is 45 degree. To the 45 degree, we have rotated the axis here. The third position you can note here, I will just zoom that area. You can note here, I rotated the axis to 45 degree here. That is, axis is O1. O1 is inclined at 45 degrees to VP or 45 degrees to XY line. Additionally, they have asked one more thing here. What they have asked here is, determine the true inclination of the axis with HP. You have to find the true inclination of the axis. In earlier problems, what we were doing is they were giving the true inclination and we were finding the apparent inclination. But in this problem, what they have done is they are given the apparent inclination. Then you need to find the true inclination. You need to find the true inclination. That is the reverse of what we have done in the previous example. So the apparent inclination is 45 degree here. We have to find out the true inclination here. The line OO2 we have to draw. For that, what we have drawn is from O1, I drawn a horizontal line here, and from point O, I taken the true length of the axis. The true length of the axis, you can note here, it is 50 mm. I taken the true length of the axis 50 mm, and with O as center, I cut this locus line drawn from O1 at point O2. Then I joined OO2 as a thin line. Then I found the inclination of that. That is the inclination, that is the true inclination of the axis with HP. That is what we are calling here as phi. Phi is equal to, I obtained phi as here 34 degree. That 34 degree I drawn here. Then after that, we have drawn the projectors upwards and we have drawn the final front view. You can note here for this problem and the previous problem, the difference. Right? In the previous problem, we had the square pyramid, but here we are having a hexagonal pyramid. In the previous problem, we had the square pyramid, but in this problem, we are having a hexagonal pyramid. That is one difference. The second difference is that in the previous problem, the solid is resting one of its edges of the base on HP, but here in this problem, it is resting with one of the corner of the base on HP. That is why one of the corner we took on the right side in case of the initial set of views. Right? Then the next difference is in case of the third position. In the second position, it is same as the previous problem. That is, axis is inclined to HP in both the cases. In the previous problem and in this problem, axis inclination has been given, but in the previous problem, axis is inclined at 45 degree, but here the axis is inclined at 40 degree. That is second position. Then coming to the third position, you can note the difference. In the previous problem, we have found the beta angle. Beta angle we have found because what they have mentioned that the axis is inclined to VP at 30 degree. But in this problem, they have mentioned the axis appears to be inclined to VP at 30 degree. That means apparent inclination is given. So no need of finding the beta angle. So the beta angle directly has been given. To that beta angle, we have to rotate the second top view. Right? Then we have drawn the projectors upwards and we have found the final front view. Then additionally, they have asked one more thing here. They have asked you to find the true inclination of the axis with VP. That is what we have done here in the final top view. We have found the angle phi. Angle phi is the true inclination of the axis. So for finding this, as I explained earlier, from point O, we have drawn a horizontal line that is called as the locus of the point O1. Then from point O, we have drawn an arc. The length of the arc or radius of the arc is equal to the true length of the axis, that is 50 mm. With 50 mm as radius, O as center, we have drawn this locus line at point O2. We have joined OO2, that is the true length of the axis. Whatever the inclination of the true length of the axis is called true inclination. That true inclination we have found here as 34 degree, that we have to write here. So that is what the second problem, first problem of the day, that is hexagonal pyramid. I had drawn it, already I had drawn it. Now we'll go for the next problem, that is a pentagonal pyramid problem. This I will draw it once again, right? Already I drawn the XY line, VPHP I drawn. I will go for drawing the pentagon now, right? I will go for drawing the pentagon with a thick line and continuous line, right? Pentagonal pyramid of 25 mm sides. So top view of the pentagonal pyramid I have to draw 25 mm, 0 degree, 25 mm, 72 degree, 25 mm, 144 degree, then 25 mm minus 144 degree and 25 mm minus 72 degree. The pentagon has been constructed like this. Then I have to look at the initial position. In the initial position, what they have mentioned here, the axis of the pentagonal pyramid is resting with one of its edges of the base on HP. One of its edges of the base on HP means it is the edge condition problem. So we have to rotate this pentagon such that one of the edge is vertical and it is to the right side. So I will take one of the edge here. I will make that as vertical and to the right side. You can see on the right side, I made one of the edge vertical and it is on the right side. You can see. Now I have to mark the axis point. So for that, I will go for thin line and continuous line. I will join the perpendicular bisector of the opposite edges. I want this midpoint here. For that, I will go to Tools, IntelliSketch, midpoint. I will turn on here. Then I will get the midpoint here. Similarly, from this point also, I join it to the midpoint of the opposite side, right, where they will meet. So these two perpendicular bisectors where they will meet, that is the point O in the bracket O1. I will just zoom this area so that it will be clear for you, right? So this is the point O in the bracket O1, right, in the top view. And these points will mark here is the point A. Let us change the font here, Times New Roman font. This is A, this point is B, and this is the point C, this point is D, and this point is E. Here, as it is a pyramid, we have to join the line joining the apex to the base corners with a thick line. So I will take the thick line, I will join the apex. So this is the apex actually. Apex should be joined to the base corner with a thick line. All the base corners are to be joined with the apex here, right? I am joining them with a thick line like this, right? Because in the top view, they are visible, right? So we have to make them thick. Now we have to draw the front view. So these extra lines I can trim off here. So this line is not required. This also not required. I'll trim it, right? This is how the initial top view looks like. Now we have to go for drawing the front view. I'll project all these lines to the horizontal, that is vertical plane, right? We have drawn the projector line from the various points here like this, right? Then from the point O also, I will draw the vertical line here, right? Extra line I will trim off here. Then from point O1, I have to draw the axis height, right? I will take a line type as axis line and 0.25 mm thickness. The height of the axis, you can note here, height of the axis is 50 mm. So I will take 50 mm as the axis height, 90 degrees. So this is the apex. Now the apex has to be joined to the base corner with a thick line. I'll change the line top now, right? So I will join here to here, here to here, then here to here, then here to here, then this one, right? I joined all these with a thick line. So this also I have to join with a thick line, right? This is how we are drawing the initial front view. Initial front view has been drawn like this. We'll mark these points here. So this is the point O dash and here is the point O1 dash. That is your axis. The base edges you can mark here. This is A dash. This point is B dash in the bracket E dash. And this point is C dash in the bracket D dash. You can see now the initial set of views have been drawn in such a way that one of the edge of the base is vertical and it is onto the right side. Now we have to consider the second set of views, inclination of the axis with HP. What is inclination of the axis with HP here? Inclined to HP at 45 degrees. That inclination will consider in the second front view. So I'll copy this first front view now. Whatever the first front view is there, I'll copy that first front view. I will make a copy now. Move, create copy on. I will just move here, right? I'll just move here. I'll keep it like this, right? Sorry. I have to just copy here. I just copied, right? You can select like this. Then use move command, right? See that create copy is on. You select C dash D dash as the reference point for moving. Then move it onto this XY line. This C dash D dash should lie on XY line. Whenever you move the cursor here, the point on marker should coincide on the XY line. Like this, you can move, right? Right click now. So this is an extra line. You can just delete that extra line. Now you select the whole second front view, right? Whole of the second front view. You can select like this by holding the shift key, or you can make a window like this. It is selected. Now we have to rotate. Use the rotate command. While rotating, you see that create copy is turned off. It should be turned off. As I told, we have to rotate the axis to an inclination of 45 degree, but directly I cannot rotate the axis to 45 degree. Instead, I will rotate the base to 90 minus 45 degree. So this base I will rotate now. So I have to rotate to an inclination of 45 degree, because 90 minus 45 means it is 45 only. So these lines I will delete it. So these lines are not required. I will just move the this particular front view nearer to the initial set of views. I'll just move like this so that I will have space for drawing the third position. I will mark these points now. Take the line tool. So this is the point O dash, and here is the point A dash, and this point is B dash in the bracket E dash. You can mark like that, right? Then this point is C dash in the bracket D dash, and here is the point O1 dash. Mark all those points. Now you draw the projectors downwards. Take a line tool, thin line only you can choose, right? You draw the projector line, vertical projector from point A dash, then from point B dash, from point C dash, like that. You draw the vertical projector. Then you can draw the horizontal projector from A, then from B, like this you can draw. Then from C up to here, then from D up to here, then from E up to here you can draw. The vertical projector from O dash also I have to join, that can be drawn up to here. Extra lines you can trim off. Use the trim tool. Wherever the extra lines are there, those lines you can trim off. Mark these points now. So this is the point A, here is the point B, this is the point C, this point is D, here is the point, sorry, here the point E comes here. Yeah, it should be E, the point O comes here. So this line I have to extend here, right? The point E comes here. Yes, right? Then from the point O1 dash also drop a vertical projector where it meets. So this is your point O1 dash. So this is the point O1 dash. So this O dash to O1 dash you have to join with a axial line, that later we'll do. Now we have to join the outer edges with a thick line. Take the line tool, thick line only and continuous line, join all the outer edges, that is A, then B, then C, then D, then E. But sorry, these are not outer edges, isn't it? Right? So A to B is an outer edge. Then B to O is an outer edge. Is it outer edge? B to O? No, it is not outer edge. Then B to C is an outer edge. C to O is an outer edge. Then we see whether C to D is an outer edge. D to E is an outer edge. Likewise, all outer edges you have to join with a thick line. Right? All outer edges I joined with a thick line. Then inside lines should be hidden. Right? Those here, the hidden line is only the line joining C to D. Line joining C to D, it should be a hidden line. So draw that and mark it as a hidden line. Right? Mark it as a hidden line. So if that is hidden line, A to O also will be a thick line. Select that A to O and it should be a continuous line. A to O should be a thick line. Right? So this is how we have to draw the second set of views, wherein we have marked the outer edges with a thick line. When you look from the top, the apex is near to the observer, the base is away from the observer. All the base edges should be actually hidden lines, but outer edges you cannot make them hidden lines. Only the inside edges, that is the edge C to D, is an hidden line that we have marked. Then we have to join the axis actually. So axis should be drawn with an axial line. I will take the axial line here, 0.25 mm thickness. Then O1 to O, you have to join as an axial line. Here it is not O dash, it is O1 only, isn't it? We are joined as written as O1 dash. It is not O1 dash, it is O1 only. So this is your second set of views. So after drawing the second set, we have to go for looking at the third set. In the problem statement, what they have mentioned. So axis appears to be inclined to VP at 40 degree. It is similar to the previous problem. In the previous problem also, we have seen axis appears to be inclined. Here also axis is appearing to be inclined to VP at 40 degree, means we need not draw the that is apparent inclination. We have to directly rotate to the given apparent inclination. So we'll take the thin line, right? We'll draw an inclined line of 40 degree here, right? I'll draw an inclined line of 40 degree. 40 degree means 180 plus 40 means it is 220 degree. I have to give the inclination here, 220 degree. I have given the inclination. So then this inclination of this line will be 40 degree. You can note. Similarly, the inclination of the axis with HP is 45 degree. That also you can show. Right? Now we have to rotate the second top view, right, to the given inclination. So copy this second top view here, right? I copied the second top view. Use the move command. Create copy on the point O should lie on this 40 degree line. Then use rotate. Use the rotate command. The point that is just not copied. So what happened? Yeah, I'll just copy here. So this line, this second top view. Use move. Create copy on. Right? I have to move here. O. I have to keep it on this. Then I will rotate. Use rotate. O to A. O to O1 also. It is the same as O to A. Rotate here like this. Right? This is an extra line. I will delete that extra line. So here extra lines you can trim off here. Right? So these points are rotated. No problem. A, B, C, D. E has not come here. I can mark this as E here. Right? I rotated such that the apparent inclination of the axis is 40 degree. Apparent inclination of the axis is 40 degree. You can note now. I'll just zoom this area for clarity. So you can see now, right? Apparent inclination is 40 degree, but I have not rotated properly here. There is some problem with the rotation. I have not kept it properly. You can see now here. You can zoom this area. You can see that point O is not on this line, right? So we have to rotate properly. So I will do that once again. I'll just delete it, right? I'll select this whole thing. Use move command. Create copy on the point O. I have to select. I have to keep it on this line. That is, when the line on element or point on element marker appears, then click. Then you have to rotate. Use rotate. While rotating, you have to select your endpoint marker. Here also endpoint marker. Then rotate. Now you can see it is properly rotated. If I zoom now, the point O lies on this 40 degree line. That is correct. Point E is also here. Now we'll draw the vertical projectors upwards. Right? Take the line tool and thin line, projector line drawn from A and A dash. So here I'll take up to here, say projector line drawn from B and B dash. Up to here, say projector line drawn from C and C dash. Here it is. Projector line drawn from D up to D dash. Here it is. Projector line drawn from E and E dash is up to here. Then from the second front view, I will draw the horizontal projectors here. So it is A dash. So this point is B dash here. C dash is here. D dash is here. E dash will be here. This extra line I will trim off now. Alright. Then from point O also, I have to draw the vertical projector. I will draw the vertical projector from O and horizontal projector from O dash, where they will meet. That is the point O dash. Extra line I will trim now. Now the outer edges you have to join with a thick line. Take the line tool. Thick line only you can choose. So these are the points here. So for example, this is the point A dash. This point is B dash. This is the point C dash. And this point is D dash. And here is the point E dash. And this point is O dash. Likewise, mark these points. Outer edges we join with the thick line now. Take the thick line, right? Continuous line. So O dash to A dash to O dash, outer edge. O dash to C dash, outer edge. C dash to D dash, D dash to E dash, and E dash to A dash back. Outer edges we have joined with a thick line. Now look at the final top view from the bottom. When you look from the bottom, ABCD is near to the observer, apex is away from the observer, meaning that ABCDE, that is the base of the solid, will be visible. Base of the solid will be visible. So you have to make them thick line. All the base edges you have to join with a thick line. So A dash to B dash, B dash to C dash, then B dash to O dash, they are to be joined with a thick line. For remaining, you have to make them as hidden line, that is O dash to here, E dash is a hidden line, then O dash to D dash, it is a hidden line. You mark the hidden line. Then axis points we have to mark now, right? For marking the axis, we have already marked a vertical line from O. From O1 also, we have to draw a horizontal vertical line, right? From O1, we'll draw a vertical line like this, right? From O1 dash, I will draw a horizontal line like this, right? Where they will meet. So that is the point O1 dash. So this point, I'll mark it as O1 dash. So this is the point O1 dash. You can mark here, right? O1 dash. Now O1 dash to O dash, you have to join as an axial line. Take the axial line to join and 0.25 mm line thickness. You join O1 dash to O dash as an axial line. So this completes the solution. That is first part. What it says is axis is inclined to HP at 45 degree and appears to be inclined to VP at 40 degree. That we have done. So they asked a next level also. What they asked is determine the true inclination of the axis with VP. It is similar to the previous problem. So we have to zoom this area, right? From O1 dash, sorry, O1, we'll draw a locus line. I will take a thin line here. From point O1, I will draw a locus line. Then I have to take the radius is equal to the true length of the axis. True length of the axis is 50 mm. I will take O as center, 50 mm as radius. I will draw an arc now like this, right? I will draw an arc. Now I will join this point O, this with intersection point here, right? This intersection point I will join, right? So this is the point, say O2. I will call it as O2. Inclination of the O2 I have to find. That is the true inclination of the axis with VP, right? True inclination of the axis with VP I can find like this. So this is 27 degree. I can write that now. Here I have to write that. I will take this text tool. I will change the font to now symbol font, right? Symbol font. I will write here phi. F, if I type phi symbol comes, phi is equal to 27 degree I want now, right? For obtaining degree, I'll go to insert, character map, right? In the character map, I'll find out the degree symbol, select and copy. Now I'll close it. I'll go to the text, that is this particular text, right? I'll just press Control V here. It is pasted, right? I will delete the extra characters here, whatever has appeared here. Those extra characters, I will delete them. Press the delete key. Only degree symbol will be left over there, right? You can make this text box smaller, right? I can make it to fit within this box like this, right? This is phi is equal to 27 degree. That is the answer for the second part. The second part is determine the inclination of the axis, true inclination of the axis with VP means. So this is the true inclination of the axis with VP. I have to do the dimensioning also. So use the dimension tool and dimension it. So whatever the sides are there, the side of the pyramid and the axis length of the pyramid, you have to dimension. So this completes the solution. So it is a pentagonal pyramid resting with one of its base edge on HP, and the axis is inclined to HP at 45 degree and appears to be inclined to VP at 40 degree. You have to also determine the true inclination of the axis with VP that we have found here, right? This is your second problem what we have solved today, right? Now we'll go for the third problem of today. So that is a cone problem, right? Till now what we have solved is the problems consisting of the corners in the solid. So here it is a pentagonal pyramid or hexagonal pyramid or square prism. In all these solids, there were corners of the base. But here, in case of the cone, there were no corners. The base of the cone is a circle, right? And an apex will be there, right? So that cone we have to draw now, right? Base of the cone is a circle, so we can draw the circle here by center point method. Circle of diameter 50 mm. So I'll choose the continuous line and thick line here, right? I will place the circle here. Circle of diameter 50 mm. Diameter 50 mm I will type. So this is the circle of diameter 50 mm. Now I have to divide this circle into 8 equal parts. For that, I will take a line tool, thin line. I will join this center of the circle with, I will draw a horizontal line like this, right? Now I have to draw the vertical diameters also. The horizontal diameter and vertical diameter I can join like this, right? I can join like this, no problem, right? So I'll join the horizontal and vertical diameter like this, right? Now I have to divide this into 8 equal parts, means I have to draw another line like this here also. That is at an inclination of 45 degree. I can draw another line here. So here also I can go for drawing the line. Sorry. Yeah. I can draw another line this side also. So this is minus 135 degree. Angle you can give it as minus 135 degree up to here. So this side I can give the angle as here 135 degree. So this is 135 degree up to here. Then I have to go down like this. This is minus 45. Angle I can choose as minus 45 and up to the line on this. So this is how we are drawn the various. This line, whether I have drawn properly? No. Right. I will draw it properly. Right. So this I have to draw at an inclination of 45 degree and it has to touch the circumference. Now we have drawn the circle here. I'll just zoom this area for your clarity. Right. You can see how it is drawn. I will mark these points now. So this is the point A. Sorry, I have to change the font now. Right. Font as Times New Roman font. A. This is B. This point is C. This is the point D. And this point is E. This is the point F. This is the point G. And this point I will call it as H. And this apex is O in the bracket O1. Apex is O in the bracket O1. Now I will draw the horizontal line, that is vertical projectors now to draw the front view. For drawing the front view, I will move like this. So from all these points, I will project up to the XY line, right? From point EF also I will draw vertical line here. From point E also I will draw the vertical line. Then from this point, I have to give the axis height. Axis height is 60 mm. So 60 mm at an inclination of 90 degree. Then I will join. Then outer edges I will join with a thick line. From here to here, I will join with a thick line. So these lines also I will join them as thick line here like this. Like this I will join. And inside lines, they will not be visible because they are not the edges. They are just drawn for the construction purposes. So these lines I will just draw for the construction purposes. So this is the axial line. I will change the line type to axial line now. We will mark these points now. So this is the point O dash. Here is the point O1 dash. And the base edges, base points I can mark here. A dash. Here this is B dash in the bracket H dash. And this point is C dash in the bracket G dash. And this point is D dash in the bracket F dash, and the last one is the point E dash. So initial position we have drawn here. In the initial position, so the whole of the base of the cone, that is a circle. Circle is on horizontal plane and our axis is perpendicular to XY line, perpendicular to HP or perpendicular to XY line. Now we'll take the second position. Here in the second position, you can note here, generally what we are solving in all the previous problems is that for the drawing the second position, they usually used to give the inclination of the axis with HP, right? They were giving the inclination of the axis with HP, but in this case, they are not given that particular data. Instead, they have mentioned that apex of the solid is at a height of 40 mm above HP. So we'll take a line tool now, a thin line, continuous line. at a height of 40 mm. I will draw a height of 40 mm here, 90 degrees. So this is the position of the apex. This is the position of the apex they are told. With this, we have to redraw the second top view. We have to redraw the second top view. Now for that, what I will do is, I will measure the distance from O dash to this F dash, right? I have to measure the distance from O dash to F dash like this. What is this distance I have to measure? I got the distance here. So that distance is here, you can see it is 65 mm. So this is the point O dash actually. So this I will call it as the point O dash. O dash has come here. We have rotated this first front view such that O dash comes here. Then this O dash E dash, it comes here. So what I will do is, I will make a copy of the first front view here. I will just copy this whole thing, right? I will copy that whole thing, right? I will make move command now, move, create copy on. The point O dash should lie here. It should go like this. Point O dash should go like this, O dash, right? And this point E dash should appear here. I have to rotate such that this point E dash should come on this line. For that, I will use the rotate tool now. Use rotate tool. I'll choose this point E dash, right? Like this, I have to rotate such that this point E should lie on this XY line, right? It will lie on the XY line. Is it rotated properly? I have to check that now. Is it rotated? No, it is not rotated properly. So for that, what I will do is, I will draw this line, inclined line first, 65 mm. So I will take an arc tool now, right? With O dash as center, 65 mm as radius. I will draw an arc here. Then I will join this point O dash with this E dash. So this is the point E dash actually. So this is the point E dash. So E dash should come here. Now I will rotate I will make a copy of the first front view and I will rotate to that, right? So for that, I will select the whole thing here, right? Then I will use move command, right? Create copy on. The point O dash should lie on here. Then I will rotate, use the rotate command, choose O dash to O1 dash, right? But not O dash to O1 dash. You have to choose for rotation. You have to choose here, right? This O dash to E dash. You have to choose O dash to E dash. You have to rotate like this, right? You are rotated down such that the apex is at a height of 40 mm from the XY line or from HP. You can see here this length is 40 mm, right? I'll slightly move this to the right side so that we can draw the second position properly. I will use the move tool, right? Create copy of the point O dash, E dash. I'll just move here like this so that I will have space for drawing the second position. I will mark these points now. I'll just zoom this area so that it will be clear for you. So these points I will mark. So this is the point A dash. Here is the point B dash in the bracket H dash, right? And this point is C dash in the bracket G dash, and this point is D dash in the bracket F dash, and E dash already I have marked, and this point is O1 dash. I will draw the projectors downwards now. I'll take the line tool, continuous line, thin line. From point O dash, I will drop a vertical projector. Then from point A dash, B dash, etc., I will drop the vertical projectors. Alright, these vertical projectors I will draw like this now. Right, from E dash also I will draw the vertical projector like this. Then from these points I have to draw the horizontal projector here. Like this, I will draw the horizontal projector. Extra lines I can trim off. Right, I will use the trim command. I will trim off these extra lines. Right. So this point is point O. The point O comes here. Then I have to mark these points here. This is the point A, point B comes here, point C comes here, point D comes here, point E, point F, point G, and point H. All those points comes here. I'll just zoom that area so that it will be clear for you, right? We have to draw here the ellipse. Ellipse should be drawn. So in the second top view, the circle will be seen as an ellipse. So for that, I will use the ellipse tool now. Ellipse by the center point method. The center of the ellipse is this one. The minor axis is from here to here. The major axis is up to this point G, right? Up to this point G. I can zoom that area so that I will have a better control here, right? So this point G up to here, right? So this is how we have drawn the base. That is base circle in the top view has been drawn. Then I will join the outer edges with a thick line. The point G should be joined to the point O here, and it should be joined to point E, like this, the outer edges. Then the base circle will not be visible actually. It should be the hidden line, but the outer edges cannot be hidden. We have to make the outer edges thick, and the inside edge, inside lines, we have to make it dark. The whole thing I will make it dark now, right? So these lines actually it should be hidden line. For that, what I will do is there is one command called as split command. I will make use of that split command now, right? There is a split command. I will use that split command, right? I will choose this and I have to split, right? So I'll just zoom this area so that it will be clear for you, right? I have to split this into two parts. Here and here I have to split. So I'll use the split command. I'll select here, right? Right? Here it should be split. Is it split into two? I'll just check. Yeah, it is split now. So this line I have to make it as a hidden line. I will use that hidden line now. So this is how it has been drawn. And this is the point O1, right? O1 to O, I have to join as an axial line. So this I will trim that, right? Use the trim command, right? So here I'll trim this area, right? Use the axial line now, axial line, and 0.25 mm thickness to join from O1 to O. O1 to O, we can join as an axial line. So this is how we are drawing the second position. The second position has been drawn here such that the base circle is seen as an ellipse. The outer edges we are joined with a thick line here. Then coming to the third position, in the third position they are told here axis appears to be at 60 degrees to VP. So this axis is here, it is horizontal. We have to make it inclined at 60 degrees. So we will take a line tool now, thin continuous line, thin line. I will take a line tool now. The angle should be 60 degrees. 60 means 180 plus 60, that is 240 degree I can take here. So this is 60 degree, right? This angle is 60 degree. You can just measure this angle, right? Angle is 60 degree. You can note here, right? Is it 60? You just zoom this area. Yes, it is 60 degree, isn't it? Now we have to rotate the second top view such that the axis is at an inclination of 60 degree, right? So we will take this axis at an inclination of 60 degree. But one problem here arises is that these midpoints, the points A, B, C, D, etc., will not be properly located. For that, what we have to do is we have to join them as thin lines. I will take line tool now, right? I will join O to F with a thin line, right? So I will get this point F, then O to this B with a thin line so that I can locate those points. Similarly, O to H with a thin line, right? O to then D with a thin line, right? So that the end points I can easily locate. G and C already they are there. Now I will use the copy command now. We'll use the copy, move, create copy on, right? So the point O, it should coincide on this 60 degree line. I will move it here, right? Then whether it is moved, no, right? I have not selected that create copy, right? You have to see that create copy is on, right? So select this point O, then move it on this 60 degree line. right? So on this 60-degree line, I moved. Now use the rotate command. Use rotate. The point O01 should coincide on this 60-degree line, right? You see, move rotate like that. Point O01 is coinciding. Now we can see that all points are here. You can easily locate A, B, C, D here, E here, F is here, here G left out. I can mark that point G here, right? The point O is here, extra line is there. So this extra line, I'll trim off here. The point O1, you can easily get here. Now we'll draw the projectors upwards. So I'll just zoom this area so that I'll get proper points. So take the line tool, thin line only you can choose, right? Projector line drawn from O and O dash. So the point O, I'll draw like this. Then point A is here, right? Join like this. Point A, then point B. From all different points, you draw the vertical projectors now, right? Then point D, point D is here. Then point E like this. Then point F like this. Then point G like this. Then from point H like this. Draw horizontal line. Then you draw projectile line drawn from O and O dash. So here is the point O dash. You can mark this point, right? So this is the point O dash. You can mark. Similarly, projectile line drawn from A and A dash. So horizontal line you have to join here. A and A dash. Here is the point A dash. You can mark that point here. A dash. Then from B dash, you can draw a horizontal line here. Projectile line drawn from B dash and B. Here it is, or else you can draw it extra, no problem. B, then C like this, you can join. Then D like this, you join. Extra lines can be trimmed off. Use the trim tool. So extra lines can be trimmed off like this. Right? So we will mark the points now. Right? So this is A dash. The point B dash, it comes here. The point B dash. Then the point C dash, it comes here. So this is C and C dash. Yes, it is C dash. Then the point D dash, it comes here. D dash. Then E dash, it is at the bottom. This is E dash. Then F dash is here. Then G dash is here. And H dash, it is here. Right? We'll zoom that area so that we'll have a clear thing. Right? A dash is there. O dash is there. All those things, extra lines you can trim off here. Right? We are having some extra lines there. So B dash. So this extra line is not required. I'll just trim that here also. That is not required. I'll just trim that. I can even zoom that area. Yes, this can be trimmed. Right? Here also this extra. I don't want that. B dash already we have marked, no? So here it is. B dash is this line. So here. So this also not required. I can trim that. So B dash easily you can get here. I can just move that. So this is the point B dash. This is A dash. This is B dash. Here also O dash extra. You can trim off here. Then C dash. Right? After A dash, B dash. Here C dash comes here. Right? So here it is. So this one is C dash here. Right? You can see. So this is up to here. Extra line you can trim here. So this also not required. Right? So this is C dash. So this one is C dash. Then D dash is here. Then E dash. So this line is not required. You can trim off that. Right? E dash, F dash is here. Then G dash is here. H dash is here. Right? All those things we have got now. Now you can mark these outer edges. You can join with a thick line. Take the thick line. Outer edges you can join with a thick line. So A dash to O dash is an outer edge here. Join with thick line. O dash to C dash or O dash to D dash. O dash to D dash is an outride. You can see here O dash to D dash is an outride. Join with thick line, right? And these actually are curve points. For that, you have to go for the curve tool here. Go to the curve tool. While selecting the curve tool, see that maintain relationship is turned off. Now draw the curve with a thick line. Thick line only you choose. Continuous line, curve. You have to choose here A dash, then B dash, then C dash, then D dash here, then C dash here, then F dash here. F dash you can see correctly where it comes this line. Okay, this is F dash, then G dash here, right? Then H dash. So this is H dash, no? Yeah, right? So here it is H dash and A dash back, right? You can join them with a curve like this. You can join like this curve, right? You can click now, right? Right click when you please, so it becomes a curve. So this line you can see it is coming inside. You have to join it as a tangent to that, right? This also it should not be drawn directly. Instead, you have to draw it as a tangent. Take the line tool here from point O dash, draw a tangent to this circle like this. Right here also you draw a tangent to this arc like this, right? Then it will come correctly. And when you look from the bottom, whole of the base is visible. That is why we have made them dark. Then axis we have marked, not marked, so we have to mark the point O1 dash now. From the point O1 dash, draw the actual line now, right? Draw the actual line. So this will come here. So this is the point O1 dash. You can mark this point as O1 dash. And this line should be a thin line, right? Mark it as thin line. And this O1 to O dash will join with 0.25 mm thickness, right? Right? You can join this O1 dash to O dash as 0.25 mm thickness, and it should be a axial line. Select this as an axial line, and this line should not be axial, that to be continuous line. So this is the solution for the problem wherein the axis of the cone is at a height of 40 mm above HP, that is apex is at a height of 40 mm above HP, and axis appears to be inclined to VP by 60 degree. So apex is 40 mm. So these dimensions also you can show here. So this is whatever the axis height is there, and what is the diameter of this. The diameter of this solid also you can show here, right? So this completes the solution wherein the cone of base diameter 50 mm and 60 mm axis length rests on a point on the circumference of the base such that apex is at height of 40 mm and axis appears to be inclined to VP by 60 degrees. So this is how we are drawing the projections, right? Any doubts, students?
No, sir.
It's clear now?
No, sir.
Okay, right.
No, sir.
There are two other problems. We'll finish off these two problems. Then that is attends this particular module. That is the second module. So we'll read this problem. It is similar to the square pyramid problem what we have solved. There is some slight variations are there. So we'll learn what are those variations. So in this problem, you can note here, it is a square pyramid of base side 30 mm and axis length 60 mm rests on one of the edges of the base. That is edge condition problem. Apex of the pyramid is at height 50 mm, similar to the previous problem. Instead of giving the axis inclination with HP, they have mentioned that apex is the height of 50 mm above HP and axis is inclined to VP by 40 degrees. So similar to the previous problem, here it is a cone, but here it is a square pyramid. So apex is at a height of 50 mm, and in the third position, we have to find the beta angle here because axis is inclined to VP by 40 degree. In the previous problem, they mentioned axis appears to be inclined, but in this problem, axis is inclined to VP by 40 degree. All right. So we'll go for solving this problem. Take the line tool, thick line only you choose, square pyramid, square it is. So I will draw the square here, right? Square of 30 mm, and it is an edge condition problem. So no need to take the angle here. The side is vertical here. So I will draw like this, right? It is vertical, right? I have to mark now the apex of the solid. I have to mark. For that, I will draw like this, right? So apex of the solid will be marked like this. So these points I will mark here. This is A, this point is B, this is C, this point is D. Here is the point O in the bracket O1. Now we'll draw the projectors upwards and get the first front view. For getting the first front view, we'll draw the projectors to the front view like this, right? Then from the apex also, I have to join here, right? Axis height, they are given it as 60 mm. So 60 mm, 90 degree, I'll join. Then I will take the thick line here. I'll join from here to here, here to here, then to here, then join like this. Then this axis, I have to mark it as an axial line. I will mark it as an axial line. Then the dimension, that is the naming of the parts I have to do. This is O dash. Here is the point O1 dash. And these 2 points are A dash in the bracket D dash. And this point is B dash in the bracket C dash. So this is your first set of this. In the second set, as I told, you have to mark the apex at a height of 40 mm, that is 50 mm from the base. 50 mm, 90 degree. So this is the point where the apex is located. This is the point O dash here. So with this O dash, I have to draw this O dash B dash. For that, I will go for dimensioning this. What is the length of this one I will find. So we can see what is this length. Yes, 61.85. Now I'll take the arc tool now, arc by center point. With this as center, 61.85 as the radius. I will draw the arc here, cut here, and this is your point B dash in the bracket C dash. Right? Now I'll join this one now with a thin line. Take a line tool, continuous line only. Join O dash to B dash in the bracket C dash here. Now we have to move this. So go for selecting here the whole thing. Sorry. Yeah. I'll select the whole thing here. Use the move command. Create copy on. The point O dash should coincide here. And point marker, you have to get that. Yes. Now use rotate. Rotate O dash to this one. Alright. It should be rotated to this line. Right, so O dash double side it's coming. I'll just delete this. Here also I'll delete it. So these points I'll mark again. So this is the point A dash in the bracket D dash, and here is the point O1 dash. Right, now you can see, so this height is 50 mm above HP. That is apex is the height of 50 mm above HP. Now we'll draw the projectors downwards. Take a line tool, thin line, right? Draw the vertical projectors here from the various points of the second front view. Like this, we can draw the vertical projectors from various points of the second front view. Then draw the horizontal projector here from the various points of the first top view. Mark the points now. So these points you can mark here. So this is the point A, this point is B, this is the point C, this point is D, here is the point O, and this point is O1. Extra lines you can trim off. Use the trim tool. So these lines are not required. I can trim off here, right? So these lines I'm trimming off, right? Here also same thing, right? Join the outer edges with a thick line. Take the thick line style here. A to B is an outer edge. Join with a thick line. B to O. Join with a thick line. So this is join with thick line. So this also join with a thick line. Thick line. And the line joining here to here, right? That is O to D is a thick line. Join with a thick line. This also will be a thick line. Join it with a thick line. Right, and this BC is an edge, that is a hidden line. So what I will do is I will just trim that. Sorry, I'll just trim this and redraw once again. Right, B to C I'll join as a hidden line. I'll take thick line thick hidden line, that is B to C, join as hidden line. And here also the axis I have to mark as an axial line. For that I will delete that. I'll go for the line tool, axial line I'll choose, then 0.25 mm line thickness, and join O2, O1 as an axial line. So this completes your second topic. Now we'll go for drawing the third set of views. In the third set, what they have mentioned is axis is inclined to VP by 40 degree. Axis is inclined to VP by 40 degree. That means we have to find the apparent inclination of the axis. I'll go for thin line here. So I'll take a line from here. 40 degree I have to choose the angle. 40 means 180 plus 40, that is 220 degree, right? So I can take any line. So this inclination is 220 degree, that is 40 degree. So this is 40, right? I have to now move this particular second top view. I'll select here, use the move tool, right? So before moving, as I told, I have to find out the beta angle. How do you find the beta angle? For finding the beta angle, I have to take the true length of the axis on this 40 degree line. Say for example, this point O, I'll take the true length here 60 mm and mark here. Then I will draw the horizontal line like this. I have to measure the apparent length now. For measuring the apparent length, I'll use the distance between tool. I'll measure the distance from here to here. So this is the apparent length of the axis, that is 46.03. I will take the arc tool now, right, with this point O as center, 46.03 as radius. I will cut this locus line. Then I will join the point O with this intersection point I have to get here, right? Yes, right. So these points are, this is the point O1 and this point I'll call it as say O2. O2, this is the point O. O2 is the true length of the axis and O1 is the apparent length of the axis. So I can find the inclinations here. Go to angle between. So this inclination is the apparent inclination of the axis. Apparent inclination of the axis is 57 degree, that I can mark here. Now I'll go for moving and rotating the second topic. I'll select this whole thing, right? Use move tool, create copy on. The point O should coincide here, right? Then I'll use rotate. Then I will choose this axis, the line O1. Then I'll select here like this, right? I rotate it. Now we have to draw the vertical projectors upward. Take the line tool, continuous line. So these points I have to mark properly, otherwise difficult it is, right? So I have not marked those points. So this is the point A. So this point is B. The point C is here, point D is here, point O is here. Now we'll go for drawing the vertical projectors. Take this and draw the vertical projector. This vertical projector from O and A and A dash. Here it is A dash we have to get here. Similarly, B dash will lie here only. Then C dash will lie here only. Then D dash, where it is, here it is. Yeah, we have to mark like this. Then from point O, we'll draw the vertical line like this. O dash, we'll draw the horizontal line. So this is your point O dash. Similarly, to get the point O1 dash, we'll draw a horizontal line here. Then from here, we'll draw the horizontal line like this. So this is O dash. Extra lines will trim off. So from here also, that is A dash also. I have to draw the horizontal line. Yes. Extra lines I will trim off here, right? So these extra lines I trim. Now I'll mark these points. Take the line tool. This line drawn from A and A dash. A and A dash. Here is A dash. Then B and B dash. This is B dash. Then C and C dash. Here it is C dash. Then D and D dash. This is the point D dash. And this point is O dash. And here is the point O1 dash. Then outer edges will join with a thick line. Take the thick line, continuous line, all outer edges. D dash to O dash to B dash to C dash to D dash, join with a thick line. as the base is near to the observer when you look from the point bottom. So A dash to B dash also will be a thick line. A dash to D dash also will be a thick line. A dash to O dash also will be a thick line. O dash to C dash will be a hidden line. We'll mark that as the hidden line here, right? So this will mark as a hidden line. Then O1 dash to O dash, it should be an action line. We'll choose the action line from, and O dash to O1 dash will draw as an action line. So this is the solution for this problem. I think we have left out, what we have left out is we have not dimensioned this one, right? And the beta angle we are not shown. Inclination of the axis, that is not given actually, right? 40 mm they are told, right? So beta angle we have to show here. What is the value of beta, right? I'll click here, right? That is text tool. Click here, right? Font I will change as symbol font. I'll type here beta is equal to, what is the value of beta? So value of beta you can note here, it is 57 degree. So take that 57. Okay, type here 57 degree symbol. I'll just paste here, right? So I'll get degree symbol here. Right, I'll delete all those things. So degree symbol will come, right? I'll just extend this so that it will fit within the screen, right? Like this. Beta is equal to 57 degree. It completes the solution, right? A square pyramid of base side 30 mm and axis side 60 mm rests on HP on one of its edges of the base, and apex is at a height of 50 mm above HP, and axis is making an inclination of 40 degrees to VP. So we have to find the beta angle here. Beta angle has been found. Then